It's me again trying to make a video. Over here I have some help. This is Vali. Yep, there you go. I want to talk to you today about the graphs of elementary functions, because I think in Romania at least there is not enough accent put on it, and I want to show you a few things on how to shift, how to reflect, how to translate those graphs, and I think it's a good idea because it will show you about the functions and how the graph will look like without a calculator. Anyhow, the first elementary function that we know, of course, with the given domain, f of x equals x. So this is the first bisector, and the graph of it, it's the first bisector going up. And if you have a negative f(x), of course, it will go down. Now, the second function that we are talking about will be the f of x equals x squared. Now, the x squared function, you already know that it's a parabola. It looks something like this. Okay, so there are about 10 elementary functions. So first I'm going to tell you about them, and then I will show you how they will reflect and how they will shift on the x-axis or on the y-axis. Now, my number 3 function will be f of x equals a square root of x. The square root of x graph, it will look something like this. Something like this. It will go up. If you have a cube root of x, it will be something like this. I will show you in just a minute. So for the first three, f of x equals x, it's a line, x squared, it's a parabola, and square root of x, it will be a graph going this way. My number 4 function would be f of x equals x cubed. It will be a graph going up. Over here you're going to see on HPI, horizontal point of inflection. For my number 5 will be a cube root of x. Now the cube root of x go something like this. Okay, it will also have an HPI. If you see, those two are inverse functions. Okay, my number 6 function will be f of x equals an absolute value of x. This, it's always a v. It will be a v because everything on the absolute value will make it a positive, so everything will be above the x-axis. Okay, my number 7 function would be an e power x, and the e power x function will be always an increasing curve going up and passing through 1 over here. And then I have number 8, which is my loin function. It will be a function also going up, so those two together, they will be symmetrical with respect to the first bisector. There you go. Here. Okay, my number 9 function, it's an a power x. And the a power x, similar to the e power x, depending on a, if the base will be a number bigger than 1, it will be a graph going up. So this is for a bigger than 1. And if I have a number less than 1 over here, my graph will be decreasing. I'm going to show you in just a few minutes. And the log base a of x also is depending on this a. So if my a would be a number bigger than 1, it will be a graph going up. Now you're going to see in just a few minutes that the logs function have asymptotes. And my next function would be an f of x equals a 1 over x. These are the hyperbolas, and the hyperbolas have 2 pieces because you cannot have a 0 on the denominator. This one will look like this. And starting number 12, I'm going to have the trigonometric function, but mainly are the 10 function because the a power x and the e power x are considered to be similar functions, or the e power x, it's a particular case of the a power x function. And on number 12, as I said, the sine function, cosine, sine of x, cosine of x, and tangent. Here we are working a lot with this trigonometric function. The sine of x will always start from 0. It's a periodic function. And the cosine of x will always start up here from 1. It's also a periodic function. Okay, this I should go a little bit more. Okay, and that's about it. So what I want to show you is how those graphs will translate and how they will shift. Okay, so things are fairly simple. I will take an example so you know what I'm talking about. So for my first example will be, I'm going to work with the x squared function because it's the most common. For instance, how would you graph the graph of, how would you make the graph of x squared plus 1? Now, because you already know that the function of x squared, you have seen it, or it was my number 2 function, the x squared function would look like this. Okay, plus 1 will make a movement in the graph up, because plus 1 it will generate the graph to move up 1 unit. So it will go through here and my graph will look something like this. Okay, this would be the graph of my x square. Now if the plus 1 would be inside my number 2 example, if I would have an x plus 1 all square, my graph would move left or right. So remember, if you have a plus c or a minus c, the graph will move up or down on the y-axis. But if you have the number inside, minus c plus c, it will move left or right. Now in my case, you have to think about whatever the vertex of this parabola will be, wherever makes this equal to 0. So if I make x plus 1 equals 0, my x will be negative 1. So in my negative 1 over here, I'm going to have my vertex, and also the original one looked like this. Okay, and my new function, okay, there you go, it will pass through 1. Okay, okay. Now if I would have with a minus 1 over here, so remember, if you have a positive number, my graph will move on the left, inside or closer to the x. If I have a negative number, you will move to the right. So remember, if I have my constant plus c or minus c will move up or down. If it's positive, I'm going up. If it's negative, it's going down. And if I have inside my constant, if it's plus 1, I'm moving left, and if it's negative 1, I'll move to the right. So over here you have to change the sign to make your movement. Okay, and I also want to show you, if you have, for my number 3 example, if you have with a negative, or if a negative shows up, what would you do? So if I have f of x equals negative x squared plus 1, how would you graph this one? Now, the graph of the x squared function, the original one, also looks like this. You already know it. Okay, the negative x squared, you will make a shiftment over the x-axis, so you will bring the graph below the x-axis. I'm gonna go something like this. This will be the negative x squared function, and then plus 1 will make a movement in my new graph up 1 unit. So I'm going with this graph up 1 unit. So my graph should be something over here. I'm going up 1 unit. So this would be my new graph over here, with the negative 1 and positive 1, of course. Now, let me give you my number 4 example. So if you have an f of x equals, I'm going to go with a negative x minus 2 square. Okay, that's it for now. My graph will be, now let's see, the x square function looks like this, the original one, right? The x minus 2 square function, it means of movement in the right hand side, 2 units to the right. Okay, so I'm going 2 units to the right. This would be my vertex. My graph will be also like this. Okay, okay, and then since you have a negative in front of the whole thing, the negative will bring it down. So my whole graph will be something like this. Okay, oh, that's an ugly looking graph. Okay, okay, and over here all you have to do is just think about through what number you will pass. Just replace x with the 0. If you're replacing it over here with the 0, you're gonna have a 2 square with a negative, but it's in the parentheses, so this will be a 2 square, which is a 4. With the negative in front, it will give you a negative 4. So your graph should pass through negative 4 over there. Okay, so these are the 4 possibilities that you might have. A plus constant or minus constant means a movement in the graph up or down. If you have a parenthesis inside, then your movement would be left or right, but remember, you have to change the sign. So if you have a positive, you should go to the left. If you have a negative in front of the x squared function, you will bring the graph below the x-axis, so you will reverse it. And the other one, same thing. If you have a negative over here, just figure out how this graph will move and then bring it below the x-axis. Okay, now if you have a plus 1 over here, this number will go up 1 unit. Okay, I want to give you another example with maybe f of x equals absolute value of x, for instance. If you need to graph absolute value of x plus 1, I think this is pretty obvious. You gotta go, because I don't know if you remember, but the absolute value function looked like a v. Okay, and if you have the plus 1, the constant inside, you gotta move to the left or right. What do you guys think? I'm gonna go in negative over here in -1 with the vertex and make my graph something like this, okay? And over here you have to think about what is the point. I'll give you another example. I want to talk to you about the hyperbolas. For instance, if you have a 1 over x plus 1, or let's make it a -1 or -2, whatever, it doesn't matter. -2, for instance. This means since the constant is next to the x, it means my graph will move to the right 2 units. So the original hyperbola was 1 over x, looked like this. And 1 over x minus 2, this will generate an asymptote in 2. 1, 2. Over here I'm going to have an asymptote. And my new graph will be something like this. Over here and over here. Okay, so this would be my 1 over x minus 1, or 1 over x minus 2 function. For the hyperbolas, I think it's fairly easy. So the bottom will generate a VA, the so-called vertical asymptotes. But if you have a +3 over here, this will be how do you call those, horizontal asymptotes. So the +3, for instance, you will give me an asymptote also like here. So I'll have this one, and my graph will be whatever quadrants you need to cover. Now if you have a negative, the quadrants that will be covered will be 2nd and 4th. Okay, let me give you an example so you know what I'm talking about. Okay, there you go, my little one. So for instance, if you have, for number 7, if you have f of x equals, okay, I think my son needs me. He's all covered in green. This is my last example because my son needs me. There you go. So if I have a hyperbola, and this bottom will generate a VA, a vertical asymptote in -2, because -2 will make this equal to 0. And this -3 will generate an OA, an horizontal asymptote over here, -1, -2, -3. Okay, so these are my asymptotes. Now, since you have a negative over here, the quadrants that will be covered will not be 1st and 3rd, but it will be 2nd and 4th. Now over here, what you might want to do is determine the y-intercept over here. You just gotta make x equals to 0 and see what's that point. And this quadrant over here, of course you have to use whatever. When you make this equal to 0, it will give you this point over here. Okay, that's about it. Thank you so much for watching. Bye bye.